JWST discovers life on K2-18b. The James Webb Space Telescope has stumbled upon DMS on the exoplanet K2-18b. This discovery is nothing short of thrilling, as finding this molecule in a planet's atmosphere could serve as strong evidence for life as we know it. But a crucial question has continued to linger in the minds of scientists. What role could this play in the quest to uncover signs of life beyond our planet? Join us as we delve into the intriguing realm of how the JWST just discovered life on K2-18b. Before the James Webb Space Telescope was launched, scientists were worried about the role of their quest to uncover signs of life beyond K2-18b and the universe. The considerable delay in its launch provided ample time for extensive contemplation and speculation on the potential contributions it could make in this intriguing pursuit. Despite not being explicitly designed for the primary purpose of searching for extraterrestrial life, the JWST was crafted with the mission of observing in the infrared spectrum, with a focus on characterizing the earliest stars and galaxies in the vast expanse of the universe. However, given its status as a formidable space telescope with a substantial gap, the realms of astrobiology and exoplanet studies were also within its interest. Interestingly, Webb has its unique ability to characterize the atmospheres of exoplanets within specific constraints. This capability surpasses that of its predecessor, the Hubble Space Telescope, widening the scope of exploration into K2-18b and its discoveries. Although its primary objective revolves around the study of distant space phenomena, there existed the tantalizing possibility that, amidst its observations, the telescope might chance upon distinctive signatures hinting at the presence of a biosphere on an extraplanet. This anticipation was particularly heightened when considering already known TRAPPIST-1 extraplanets. The TRAPPIST-1 system was anticipated to enhance our understanding of its atmospheres. By observing the transits of multiple planets across their stars, scientists aimed to glean insights into how these atmospheres influence light. While the primary objective was to gain knowledge about extraterrestrial atmospheres and potentially detect signs of life, the JWST held the possibility of unexpected discoveries. The current developments, however, surpass initial expectations and introduce a fascinating revelation. In close proximity to Earth, an unusual planet has captured the attention of astronomers, promising not only to broaden our comprehension of the planets in general, but also hinting at the existence of an alien biosphere. This particular outer space body, known as K2-18b, had been identified previously. Classified as a large super-Earth or a mini-Neptune, it stands out with its substantial mass, approximately 8.6 times that of Earth, and a diameter 2.6 times greater. Typically, a planet with such high gravity would be considered inhospitable for life. Yet, K2-18b introduces the possibility of a unique space category that could potentially support life, presenting a departure from our familiar type of habitable extraplanet. Located around 124 light-years away in the Leo constellation, K2-18b holds the promise of unraveling mysteries that extend beyond our solar system. A remarkably cool celestial entity known as the Red Dwarf, K2-18b, significantly dwarfed and cooled compared to our familiar Sun. Its radius is merely 45% of that of the Sun, adding an element of cosmic peculiarity to the mix. The debate surrounding the habitability of red dwarfs has been an enduring saga. Theoretically, these stars could harbor life under specific conditions, but the flip side presents potential challenges. Planets in their orbit tend to be tidally locked in the habitable zone, facing potential flare activity from the star, leaving the scientific community in a state of uncertainty. Red dwarfs, despite their enigmatic nature, constitute the most abundant stellar type in the vast expanse of the universe. Complicating matters further is the wide spectrum of activity among red dwarfs, with some being more dynamic than their counterparts. The question of how these stars flare remains elusive. Recent studies hint that flares may not occur at their equators, providing a glimmer of hope for the safety of any orbiting planets. This opacity can lead to challenges, including false detections and uncertainties in understanding these cosmic configurations. Within this stellar system, 2 planets have been identified: the enigmatic planet under scrutiny and an additional celestial companion, adding to the planet intrigue that captivates astronomers and stargazers alike. Yet, the allure of understanding these enigmatic realms comes with its own set of challenges. Flares and star spots add layers of complexity to our attempts to decipher their mysteries, urging caution against hasty conclusions. Readings initially deceiving demand a second glance, as the world planet may transform upon closer inspection. The study, however, distinguishes itself by not relying solely on a solitary observation. Instead, it weaves a narrative based on 2 distinct perspectives. Nestled within the habitable zone of a red dwarf, this planetary companion completes its celestial journey in a mere 33 days, skirting the star in proximity that raises questions of tidal locking, though uncertainties persist. The planet's density hints at an identity that hovers between the realms of Neptune and Earth, capable of retaining hydrogen, albeit imperfectly. The conundrum unfolds. Will it be a rocky, terrestrial entity distinct from Neptune, or will it echo the characteristics of the gas giant? K2-18b was born into a relatively youthful system, with an age of approximately 2.4 billion years, though shrouded in a veil of uncertainty. K2-18b occupies the coveted habitable zone. Liquid water, the magic of life, could grace its surface under the right circumstances. However, the prospect of an ocean introduces intriguing scenarios. A pressure-bound layer of ice concealing a rocky core, generating a dance of heat on the dark side if tidal locking holds sway. Yet the conditions of this distant extra-planet remain elusive, obscured by the fog of uncertainty. With possibilities ranging from a water world, shielded by a thick hydrogen cloak, to an entirely different destiny. In the delicate movement of space forces, the extra-planet navigates multiple tightropes, hanging in the balance between potential biosphere territory and the uncharted realms beyond. If this celestial neighbor had been slightly smaller, the prospect of a potential biosphere might beckon. Nevertheless, amidst the questions, one certainty emerges: the presence of water vapor, constituting about 1% of the atmosphere, a tantalizing hint at the potential wonders concealed within the enigmatic folds of K2-18b's planet pattern. New observations reveal the presence of carbon-bearing molecules like methane and carbon dioxide in the atmosphere. Although these are common gases in the universe and don't necessarily indicate the presence of life, their existence supports a hypothesis that has been circulating for some time. The hypothesis, HNO World, is a term derived from combining hydrogen and ocean. Imagine a hot, water-covered planet with a hydrogen atmosphere, potentially habitable due to the presence of liquid water. While none of these planets have been confirmed, candidates, mainly from the Kepler mission, suggest that HNO worlds could be larger than Earth, possibly up to 10 times its mass. K2-18b is one such example. K2-18b was initially considered a potential candidate for exploration due to its favorable positions relative to its star, suggesting the possibility of maintaining an ocean, a characteristic of HNO worlds. The absence of ammonia and the presence of water vapor, carbon dioxide, and methane further support the hypothesis that K2-18b falls into the category of its worlds. However, there remains uncertainty about whether the planet, even with an ocean, might be too hot to sustain life. These planets differ significantly from Earth, featuring atmospheres rich in hydrogen and other gases. The ocean beneath a high-mass gravity environment could create remarkably tranquil seas, covered by a layer of pressure ice atop a rocky core. Despite their dissimilarity to Earth, these planets might still be considered potentially habitable, albeit under conditions vastly different from our own. One notable characteristic is the likely considerable depth of K2-18b's ocean, devoid of any land masses. This unique aspect initiates the first mystery surrounding this peculiar extraplanet. Speculation arises about the potential disequilibrium of carbon dioxide in its atmosphere, a factor that could serve as a biosignature, though not a definitive one due to various abiotic processes capable of producing carbon dioxide. An additional intriguing aspect involves the spectral detection of CO2 and methane, with a potential but not yet confirmed identification of the chemical dimethyl sulfide. However, this finding is tentative, marked by sigma detection falling short of the 3 sigma threshold, typically required in astronomy for meaningful conclusions. Serious confirmation from other research teams is crucial, introducing a third point of caution. If validated, the presence of dimethyl sulfide becomes noteworthy as it constitutes a potential biosignature gas. On Earth, this compound is produced both by biological processes and industrial activities. Upcoming observations from the JWST hold the promise of either confirming or refuting this initial detection. If confirmed, the situation becomes even more intriguing, as K2-18b would exhibit not just one, but 2 separate biosignatures. Moreover, both could potentially be considered techno-signatures, though additional evidence, such as a radio signal, would be required to delve into that realm. Undoubtedly, K2-18b has swiftly risen to prominence on the list of intriguing planets. While it might be tempting to let excitement take hold, it's important to exercise caution at this early stage. What we have here is not a definite confirmation of a biosphere on a multiple planet. Rather, it's merely a possibility. The encouraging aspect is that the system is scheduled for additional observations with the JWST and other telescopes, including radio telescopes in the Search for Extraterrestrial Intelligence SETI program, are likely to join in. This recent observation underscores the remarkable capabilities of the JWST, revealing its power in exploring the universe. The discovery of a peculiar planet so early in our observations statistically implies that there are many more unusual multiple planets waiting to be uncovered. However, this planet does turn out to be a haven for life, discovered so soon in our exploration. It could suggest that inhabited worlds are remarkably common in the vast universe. In fact, HNO worlds, characterized by the potential for life, may even surpass Earth in numbers. Yet, the conditions on such planets with higher gravity could present a unique challenge. Life there might be confined, not only due to a substantial gravitational pull, but also because it is likely to be oceanic in nature. The possibility that life may be abundant in the universe, but advanced civilizations capable of interstellar travel are scarce. It poses a thought-provoking resolution to the Fermi paradox. This telescope has a knack for peering into the universe with suspicion, uncovering its hidden secrets and surprising revelations. From fully formed galaxies defying planet expectations to multiple planets exhibiting potential biosignatures, the JWST reveals a treasure trove of mysteries that left everyone in disbelief. Would we be seeing a human settlement on K2-18b soon? Let us know your thoughts in the comments below.